video go a little faster so it's not so huge. And on this one, we're actually provided with a formula, so that's good news. When we already have a given formula, we can go ahead and go to our y equals screen on our calculator. Matter of fact, I'm going to grab my calculator and join you. Let's head to our calculators, go to that y equals screen, clear out anything that might formerly be there, and let's just type in this formula. We have a negative 16. They have t squared. We'll use x squared plus 8x plus 48. And here's what all these things mean. We've got a cliff diver, and he's jumping from a ledge 48 feet above the ocean with an initial upward velocity of 8 feet per second. And we've worked problems that are similar to this, but you know, I always like to draw pictures. So you've got this platform, and it's up above the water. Let's get some blue for the water. Here's the water up here. And it's actually a cliff, and he's on this ledge up here, and he's going to dive. He's 48 feet up, so I know he starts at this level of 48 feet. So here's this little dude standing here, is all brave, about to dive. And he didn't just like do a deadfall and a plop. It says he has an upward velocity, so he's going to kind of jump and launch himself upward, and then of course gravity takes hold and eventually splash. He's going to hit the water. So his upward velocity is 8 feet per second, and the distance the cliff diver is from the ocean surface in terms of elapsed time can be modeled by this formula. So when you look and you think, well, where did that 48 come from? We can see that that 48 is the starting height, and then these t's are time, because that's what we're looking for. When. So we're looking for time. We're basically asked to solve for t. And it says that d basically is the distance he is from the ocean surface. So I want to know when he's 24 feet from the water. So if I'm at y equals, that's an understood 0 equals. And this kind of models his beginning height. But as time, and that can kind of be like your x-axis, as time ticks by, this guy's at different heights. He's a little higher than 48 feet here. And then as time keeps going, his distance from the water is getting less and less and less and less. And eventually we want to know, when does he enter the water? So when is his height 0 is what that's looking for. So I'm looking for the height at being 0 when he hits the water here at B. So I want the height to be 0. But here I want the height to be 24. So basically what you're going to do, when I lay my calculator right here, is I can go straight to my table. You can look at the quadratic quadratic equation graph if you'd like, but right now we're really interested in the data. So specifically that, I want to know when the h is 24. So keep in mind I'm looking for when is y 24. So we can scroll. Matter of fact, I'm going to tell my calculator, so just start at 0 for me. Get some weird spots here. All right, so if you're looking at the same table I'm looking at, it looks like I got, when the time is 0, remember we replaced in our calculator, we replaced these t's with these x's. So on our calculator screen in my table, I'm looking at when x is 0, before he jumps, his height is 48. After 1 second, what I have on my calculator is this. I have a 0 matching up to 48. This is my x and y. I've got 1 is 40. So after 1 second, he's already come up a little bit, and after 1 second, boom, he's already down here at, at 40 feet above the water. And at 2 seconds, boom, it says he's at 0. In 2 seconds, his height is 0. So when I'm looking for y to be 24, that's somewhere here between 1 second and 2 seconds. Matter of fact, if I look at my table here off my calculator screen, I have the answer to question B. How long will it take the diver to enter the water? Well, he hits the surface out of the water. His height is 0, right? 0 after x, that t we replaced with x, at 2 seconds. So I already have the answer to B part. I'm going to go ahead and just get that jotted down. But I've got a little bit of a problem ahead of me when I want to try to answer this right here. 24 feet above the water, 24 would fit somewhere between 0 and 40. So I know that time is somewhere between 1 and 2 seconds, but I don't know exactly where that is. And so we're going to have to use some other method besides the calculator to find that, because it's going to be, you know, kind of one of those in-between spots. So one of the best things we can do is go ahead and fill that out. 0 was what I wanted the height to be on this one, on question B, but A, I want the height to be 24. So rather than replace this with 0, I'd rather replace it with 24. So I'm just going to jot that down here. This is the equation I need to solve here. When 24 is equal to negative 16 t squared. And we can go ahead right now, since we're using x, and that's what we're more familiar with. You're welcome to do that. So x plus 8x plus 48. Remember, if we do want to factor, we want this equal to 0, so we can minus 24 from both sides. Since that's a plain integer value, I can't, got my square, I can't take that from squares or x squares or x's, so I have to take it from the 48 over here. It's like term. I'll tell you what, I'm going to go ahead and take this answer, since it's kind of in my workspace, and then just answer it. Scooch that answer right here and use this workspace. Over here a little bit. And move this over here. Okay, so now I have this equal to 0. So I have negative 16x squared plus 8x. And then 48 minus 24 is simply 24. And one of the things that I ask you to look out for is there something in common that I could factor out? And you certainly can factor out an 8. 8 times 2 is 16, 8 times 3 is 24. And if you will, you really want to go ahead and make this not negative. So instead of just factoring out an 8, let's factor out negative 8. So we'll bring down our 0, and we're just going to take this side and divide everything by negative 8. So get ready. This term, negative 16x squared divided by negative 8, or negative divided by negative will produce a positive, and that's going to be obviously 2, and then x squared. If you take a positive 8 and divide it by a negative 8, now you have a negative 1, or just minus, and I can leave it as an understood 1 here in front of this x. And then a positive 24 divided by a negative 8 leaves a negative 3, so I'll write minus 3. And then all I have to do is just factor this short, much smaller trinomial than what I had earlier. So I'll just bring down a negative 8. I have to keep up with it. It's still part of the scene here, but it's not going to be part of our factoring. So I'm going to take this trinomial, this quadratic trinomial, and we'll break it down into 2 binomials. So I'm going to have to break this lead off into 2x times x. And we're in luck that 3 is a prime number, and so we only have one choice. It's 1 times 3. But my choice now is, well, where do I put the 1 and where do I put the 3 to make this work? If I put the 3 here and the 1 there, that won't work, because now I have 6x for my outer product and 1. And that's not going to fight down to 1x. So what I want to do instead is swap places, and we'll bring the 3 here, the 1 there. And now I have 3x and 2x, and I can work with those to create this understood 1x here in the center. I want the negatives to win, so I want the bigger pile to be negative, and the smaller pile to be positive. So I have a negative 3x and a positive 2x, and that's what's going to do it. Now I just need to solve for x. If this times this times this is 0, then one of those is 0. I know it's not the negative 8 that's 0. It could be the 2x minus 3 that's equal to 0, or the x plus 1 that's equal to 0. If it's x plus 1 that's equal to 0, then this x would have to be negative 1. And if you think about it, again, when I apply that to this real world setting, it's not possible for my time to be a negative 1 second. I mean, we're not traveling backward in time. That's just not very logical for what we have to do. And so that's not going to work out. It's definitely going to be whatever x is here. So again, you can apply that mental math we talked about earlier. If 2x minus 3 is equal to 0, the first thing you're going to do is add 3 and then make it a positive 3. Then you have to come back and divide by 2. So that would also be the same as 1.5. 1.5 seconds. Now that makes sense. 1.5 seconds. That can work for us. So I could look for when x is 1.5. Let's grab our calculators now and have some digital proof, calculator proof of it. I can say, hey calculator, I need you to go to 1.5 for me. So go into your table setup here at second window, and then go back to table, second graph, and sure enough, it says, yeah, after 1.5 seconds, you're 24 feet above the water. So that's definitely, so we have confirmation here on our calculators. The answer here is 1.5 seconds. So this one could be answered simply by looking at our calculator table. This one needed a little bit closer look, using a different method by factoring is the one that we use. All right. I think we're down to our last